Hello everyone, I'm Aditi Kinkhabwala from New LJ Institute of Engineering and Technology. Let us start with the topic of Q, which is part of Unit 2, that is linear data structure. So, in today's lecture, we would be going through the basic Q definition and concepts and operations which can be performed on Q. Now, before actually understanding what is a queue data structure, let us understand the concept of queue using analogies given below. Now, see students, consider an example of people moving on escalator. So, how does it work? The people who got on the escalator first will be the first one to step out of it, right? So, the first who have entered or who have boarded the escalator is the one who will first move out of it. Similarly, people standing outside the ticketing window of the cinema hall. So, the first person in line is definitely going to get the ticket first, and then uh, he or she will be the first one to move out of that line once the ticket is obtained, right? Again, cars lined at the toll bridge. So the first car reach the bridge will be the first one to leave, right? So it is a simple queue. As we know in English, what is queue? Queue is basically a line, right? And in that line, whoever is first is the first to move out, right? So, similar way as we have seen the stack data structure, it was last in, first out. Queue is also a data structure. So, it is a manner in which we can arrange a data, right? So, we can arrange data in a queue, and how this data structure work, that we will see. So, it is a FIFO, that is first in, first out data structure, in which elements that are inserted first is the first one to be taken out. Okay, so it works in FIFO manner. We have seen that stacks work in LIFO manner, that is last in, first out. And here the queue is the first element entered is the first one to move out. So elements in the queue are added at one end called rear and removed at another end called front. Now, students, in stack, what we saw was the elements which are entered, they are entered and removed from the same end and based on the position of top. Here, Q is a position similar to this. So here insertion is done from the one end and deletion is done from another end. Now, as you can see here, this is the representation of Q. So insertion will be done from here. So whatever is inserted, right? So if suppose 2 is inserted, now 3 is inserted. So 2 will be here, 3 will be here, right? So that way, so in after many insertions, the position of Q could be like 2, 3, 4, 5, 6, and so on. And now if deletion starts, it gets deleted from the front. So the first one to enter is the first one here to get deleted. So this is the basic queue data structure, and we require, in order to implement queue, we require two variables and two pointers, which is rear and front. So you should understand rear is for insertion and front is for deletion, right? You could have, you could draw it in reverse way. You could have front over here and rear over here, but then the position also changes. So insertion has to be from rear end and deletion has to be from the front end. Now, students, Q is a abstract data type. It is basically a concept which could be implemented using arrays or linked list, right? It can also be implemented using stacks. So now let us see array representation of queues. So basically it is a linear data structure, and array is also a linear data structure, right? Sequential. So here, as you can see, this is an array, right? So this array has indexing from 0 to 9. So for example, it is 10 elements. Now, if the current position of Q is like this, that till index 5 it is filled. Now, if we try to insert one more element, it will be inserted at the sixth position, which is 45. But now if you want to delete an element, it would not be deleted from 6th because the first element to enter was 12. So deletion takes place from this front, right? So here this is the front, right? And it will get deleted, and this is the rear pointer, right? So now this is the rear pointer, and rear pointer increments, and then we can add the value inside the queue, right? So we can represent queue with the help of an array. Now, this is also the same diagram. This is in form of a vector. So at any given time, based on the insertions and deletion operations, which is also known as NQ and DQ operations on the queue, the front and rear variable are constantly changing. Okay, so front and rear variable will constantly change because of many insertions and deletions on the queue. So this is the representation of queue as a vector, right? So there are many elements possibly and many deletions also which is done on the queue. Now let us see tracing of operations on a simple queue. Now see students, this is a queue. Currently the size of queue is 4. It is empty. So when a queue is empty, both front and rear pointer are at, if this is 1, 2, 3 and 4, so currently front and rear both are at 0. Okay, so front and rear both are at 0. Now let us see. Now we will insert A. Now when we insert A, it will be inserted from the rear side. So currently rear is over here. So A will be inserted and we will increment the rear pointer, right? So first of all, rear pointer is incremented and then we have inserted A. Now students, during first insertion, we also have to increment the front pointer because now if A gets deleted, we should always make the front pointer point to the first element, right? So when the first insertion is made on an empty queue, the front pointer has to be incremented as well. Now the next one is insert B. Now after this, on insertion of B, only rear will move ahead. So we are incrementing rear and keeping the value B. Again, insert C. Now this time C is inserted, so rear pointer is incremented +1, and at that particular indexing we have placed C. If you can see, front is not changed because the first element, currently no delete operation has taken place. So this is how we need to insert element. Now let us see the next, delete A. So now the front pointer, wherever it is pointing, this element is deleted, and now front pointer will also get incremented. So front is at B and rear is at C. Now in case of delete B, what will happen? Front will get incremented and B will be deleted. Again, if we say insert D, so D is inserted and rear is incremented. Insert E. Now, when rear tries to increment and place the value, it gives overflow condition because we have already seen queue size is 4, right? And now rear pointer is pointing at the 5th position, which is not available in the queue, and hence it will come to a queue overflow error message, right? So this is how we have to trace NQ and DQ operation, that is insert and delete operation in the queue. Now students, let us see the operations on queue. The first one is queue insert, that is insertion in queue, and second is deleting elements from queue. So we should have one queue, we should have front pointer, we should have rear pointer, right? So front and rear pointers should be there. Also, see here, queue, front, rear, we should also have size. What is the maximum size that queue can hold? And y is the value, what value we want to insert, whether you want to insert 3, 2, 5. So y is actually the value. Now let us see operation algorithm to insert element in the queue. So the algorithm name is queue insert. It takes 5 arguments as we have seen. Q, front pointer, rear pointer, n is the number of that is the maximum size, and y is the value, right? So which which we want to insert. Students, you should remember that insertion takes place at rear end. Okay, so rear gets incremented, right? So in case if Q is empty, both of them points to initially F is equal to R is equal to 0. So F and R are pointers. Here, as you can see, Q consists of n elements and is basically the element which we want to insert. Prior to the invocation of the procedure, we have like F and R have been set to 0 if the Q is empty. Now, students, in what scenario we have to check whether insertion is possible or not? So, we need to first of all check if the queue is full or not. Because if the queue is full, we cannot insert. If the queue is empty, we can easily insert, but here we need to check overflow condition. Now, whenever we insert, for example, if we insert 1, so F and R will be incremented, insert 2, R incremented, 3, R incremented, 4, R again incremented, and now while trying to insert at location 5, it gives stack overflow condition, right? So if it is full, that means the size, or basically the pointer R, is greater than equal to the size. Okay, so here, for example, the pointer is at 5 and it is greater than equal to size, so which is not possible. So if the rear pointer exceeds the n, which is the size of the queue, then we need to write overflow and return. So while inserting element in the queue, we need to always check for the stack overflow condition. Now, students, what if the stack is empty? So simply we have to increment this pointer. So now rear would be over here. So R is R plus 1. We are simply incrementing. Now we will place this Y, because Y has the value. For example, Y is 5. So we need to place this Y wherever this Q is pointing. So at Q of R, we need to place the Y, right? So at Q of R, so this is R, and if this is Q, how can we access this first location? That is Q of R, and there we will place Y, because Y has the value. So this is how we can insert in an queue. Now, students, in the first insertion, during the first insertion, we need to check. Now, because it is getting inserted, we need to also check if the front pointer is set, because as soon as the queue gets some value, that means Q has 5, that means it can be deleted also, right? So as soon as first element is entered in the queue, we need to update front pointer as well, right? So if it is 0, we have to update it to 1. That means now we have at least one location which can be deleted, right? So on the first insertion, we need to make sure that it is properly set. When it is properly set, if F is equal to 0, and if we have inserted, then we have to make F is equal to 1. Okay, so this is only possible for the first step. If the queue situation is like this, right? So 1, 2, 3, and now we are inserting at 4, right? So front is already over here. We don't need to increment it, right? But when the queue is empty, we need to make sure front goes from 0 to 1 on the first insertion, right? So this is how we can insert in the queue. Now, the next algorithm is the deletion operation. So operation on queue is deletion. Now, students, deletion requires queue, front pointer, and rear pointer. We do not require Y, because here user will not decide what is getting deleted. Whatever is first entered, it will be the first one to get out. Okay. So F and R are the front and rear pointers, and Q is the corresponding Q. Okay, just here, this Y will work as a temporary variable. So this is not the value, this is just a temporary variable. While deleting, again, we need to check for underflow condition. So if f is pointing nowhere, it is 0, then definitely it is a situation of underflow because it is a empty queue. So we will write underflow and we will return 0. 0 denotes an empty queue over here, right? But what if this front pointer is not 0? If front pointer is somewhere over here, for example, this is 1, 2, and 3. This is rear pointer, this is front pointer. In that scenario, whatever is there in queue of f, right? What is there in queue of f? 1. That we will store in temporary variable y. Okay, so 1, wherever the front pointer is pointing, we are storing that in y, right? So we are currently deleting it. So that is stored in y. Now, after deleting students, we need to check whether after inserting some values and deleting some values, we have to check whether or not queue got empty or not. If the front and rear pointer at any time become equal, that means queue is empty. So we have to again shift f and r to 0. Okay. But if queue is not empty, we have to keep on deleting. So front pointer can be incremented. See students, if this is the situation, this is the rear pointer 1, 2, and 3. This is the front pointer. Now we are deleting this. So q of f will go to y, right? So we are removing this, incrementing the front counter. Front is this. Again, q of f, we will return this element that will go to y. Again, front is over here, right? Now this is 3. Okay, so we are deleting it, right? So q of f, again this time also it will go to temporary variable. So 1, 2, and 3 are deleted. Now can you see f is equal to r? That means in this index, so initially 3 elements were inserted, now 3 are deleted. So both pointers are somewhere together, and now it shows that the list is empty. So we have to again bring back to the original position where f and r are 0. And if they are not equal, that means there are still elements left to be deleted, and we can delete it by giving them to temporary variable and increasing the counter of the pointer, and then we will return this element, right? So for example, 1 is deleted, 2 is deleted. If we want to print values, or in a programming we want to return it to the main function, we can return that element. So this is how we need to perform insertion and deletion on queue. Thank you.